So every variable in Java has this compile type, also known as a static type. And this is the type specified at declaration. This never changes. This is also the type that the compiler sees. And so whenever the compiler is, checking to make sure everything works and is valid, it's only looking at the static type. Variables also have a runtime type, also known as the dynamic type. And this is the type specified at instantiation. And so this is equal to the type of the object being pointed at. This is the type we start with during runtime. So let's go through an example really quickly. Let's assume we have some sort of inheritance hierarchy where we have, living thing, and then animal somehow inherits from living thing. And then we have fox and squid, which both inherit from animal, right? Some sort of hierarchy like this. And so first we're going to say LT1 is a living thing. So the static type is what we declare a variable as, or in other words, what we're writing on our magic box, right? We say, okay, this is a box that can hold living things. And so that's the static type. We haven't actually assigned it to any value, so the dynamic type is null. There's nothing in the box yet. Then in the next line, we say, okay, we're going to put a fox there. And this makes sense. We can put a fox in a box that can hold living things, right? If our magic box can hold any living thing, the compiler is going to say, okay, you can throw a fox in there. Cool. And so the dynamic type becomes fox, and now living thing is pointing at a fox instance. Then on the next line, we're actually going to do something special called a cast. We will learn more about this later, but basically, let's say now we're trying to say animal A1. We're declaring a new variable of static type animal, and we're going to assign it to whatever this fox is. And so now the static type of A1 is animal, and the dynamic type is fox, because we're really pointing to a fox. Again, we will go over what this notation is in a moment, so don't worry about it yet. Then we're going to say variable h1 is a fox, and we're setting it equal to a new fox object. So take a moment, and what is the static type and dynamic type going to be? If you said fox and fox, you were right? H1 is pointing at a new fox instance, and it's got static type fox and dynamic type fox. Finally, we're going to set LT1 to be equal to a new squid. Take a moment and predict how this is going to change our little diagram. And so now, remember, the static type never changes, but the dynamic type, or what LT1 is really pointing to, will. And it becomes squid. And the squid is, all over our code, whatever. And so this is just a little example of how the static and dynamic type change as you're assigning variables. But here's an interesting question. What if we try doing something like animal A equals new car? And let's assume that, a car is not an animal, right? Does this work? If car doesn't inherit from animal, or in other words, we can't say a car is an animal, then this would not work. And it's the compiler's job to make sure that we are only doing assignments that make sense, right? The Java compiler is like a diligent factory inspector, making sure we only put items in boxes that they can fit in. So again, we have these magic boxes, and if we say, oh, we have an animal box, and we try to shove a car in there, the compiler is going to go, no, 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 no. Step back, you're in trouble. And it gives you an error. So the compiler is, a big part of its job is making sure that you are only doing things with appropriate types. The compiler also catches syntax errors or undefined references and things like that. When we make an assignment saying var equals value, the compiler asks, can a memory box of var's type hold something of values type? Similarly, if we call a method var1 my method var2, the compiler asks, can an item of var1's type call a method with the name my method that could take in an item of var2's type? If it can, we're going to give that method our seal of approval and write it into our records. The compiler, on the factory floor goes, okay, fine. I see that you do have this method approved. You're on my list. You're on my whitelist. You're good. So let's go over what happens when we have sort of different dynamic and static types for variables and what the compiler does when it's approving these methods, right? When we're looking for the method to run. So we have a variable p, and let's ask a couple questions. What is the static type of p? Well, that's going to be animal, right? Because that's what we're declaring it as. What is the dynamic type of p? Well, that's pig, because that's what p is actually pointing to. What type does the compiler see? So pause for a moment, think about this. The compiler only sees the static type. So as far as the compiler is concerned, p is an animal. We might know it's really a pig underneath, but the compiler is just seeing animal. And so on the next line, when we say p.makeNoise, it's the compiler's job to make sure that the method we're calling is exist and we can call it, right? As we were saying earlier, when we make method calls, the compiler goes and checks that we can really do that. And so the compiler is going to go look in the animal class, because as far as the compiler is concerned, p is an animal, and it says, animal, do you have a method called makeNoise that takes in no arguments? And it does. So we're able to call this method. The compiler gives the seal of approval to this method. The compiler writes in its records, public void makeNoise, you may run. And it keeps that record. Here's the interesting thing. At runtime, when we're running the code, we do p.makeNoise, and we're going to start at the runtime type when we're going to look for methods to run. And so the dynamic type of p is pig. So we go look in the pig class and we say, hey, like what was that method that we got approved for? And it was public void makeNoise. We're looking for a method with that, matches the one we wrote down earlier, and we find it here at the dynamic type of p. So we run this. So in other words, because makeNoise overrides or has the exact same signature as the method we found earlier at compile time, we run the overriding version and we print oink instead of hi. So in general, we can say if we call a method of an object using a variable with compile time x and runtime y, if the class y overrides the method in x, then y's method is used instead. This is known as dynamic method selection, or at least here at Berkeley, that's what we call it, right? And I sort of think of it as we pick the method in the dynamic type as long as it overrides exactly the method we approved at compilation. And so now we're going to go over a little puzzle.